There's a moment every farmer knows. The sky is darkening, storm clouds are building on the horizon, and you've got hundreds of acres of grain standing in the field, ready to harvest. Every hour counts, every minute matters. In that moment, the machine you're sitting in becomes the difference between a profitable year and financial disaster. For generations, that machine has been the combine harvester, the iron giant that cuts, threshes, and collects grain faster than anything humans could do by hand. But not all combines are created equal. Some machines were so powerful, so revolutionary, so perfectly engineered for their time, that they became legends. Today, we're counting down the top 10 most powerful vintage combine harvesters ever built. From the pioneers that proved self-propelled harvesting could work, to the monsters that could clear 100 acres before lunch, each one of these machines represents a leap forward in agricultural capability. Whether you're a farmer who remembers these beasts, a collector who dreams of owning one, or just someone who appreciates incredible engineering, you're about to discover the machines that literally fed the world. Let's dive in. Number 10, John Deere 55. Coming in at number 10 is a machine that changed everything. The John Deere 55, introduced in 1947 as one of the first commercially successful self-propelled combines. For the 55, most combines were pull-type models dragged behind tractors. John Deere's engineers asked a revolutionary question. What if the combine could move itself? The 55 featured a two-cylinder gasoline engine producing approximately 50 horsepower. Not massive by later standards, but a revelation in 1947. The self-propelled design meant farmers no longer needed a separate tractor and operator. One person could handle the entire harvesting operation. The cutting platform was 12 feet wide, and the machine could process grain at speeds that seemed impossible compared to pull-type combines. What made the 55 truly special was its reliability. John Deere didn't rush to market with an experimental design. They tested extensively before release, and it showed. The 55 worked. Day after day, season after season, it cut wheat, oats, barley, and other small grains without the constant breakdowns that plagued earlier self-propelled attempts. The two-cylinder engine, familiar to anyone who'd operated John Deere tractors, was simple to maintain. Parts availability was excellent through Deere's dealer network. Farmers loved the visibility. Sitting up high in the operator station, they could see the cutting header clearly and watch grain flow through the machine. The controls were straightforward, no complicated adjustments or constant tinkering required. You could teach someone to operate a Model 55 in an afternoon, and they'd be productively harvesting by evening. The 55 found particular success in the wheat belt, Kansas, Oklahoma, the Dakotas, where large fields made self-propelled efficiency crucial. Custom harvesters who moved from farm to farm during harvest season adopted the 55 enthusiastically. It was reliable enough to handle the brutal schedules custom work demanded. Production continued until 1953, with thousands of units built. Many logged over 20 seasons before retirement. Even today, you'll occasionally spot a restored 55 at vintage shows, still capable of cutting grain 7 decades after it was built. The Model 55 proved self-propelled harvesting wasn't just possible, it was the future. Every combine that followed owes something to John Deere's pioneering design. Number 9, Massey Ferguson 860. At number 9, we have the Massey Ferguson 860, introduced in 1974 and representing Massey's entry into high-capacity harvesting. The 860 wasn't just an incremental improvement over previous models. It was a purpose-built machine designed for serious production agriculture. The 860 featured a Perkins 6-cylinder diesel engine producing approximately 145 horsepower, channeled through a sophisticated variable speed drive system that gave operators precise control over ground speed independent of engine RPM. This was advanced technology for 1974, allowing farmers to match speed exactly to crop conditions. The grain tank held 115 bushels, substantial capacity that reduced trips to unload. The cutting platform could extend to 20 feet wide with optional headers. Massey Ferguson engineered the 860 with their power flow feeding system, which used aggressive augers and drum designs to keep crop material moving smoothly into the threshing mechanism. This reduced plugging significantly compared to earlier combines. The separation system used a conventional straw walker design, but Massey optimized the walker length and aggressiveness to maximize grain recovery while keeping losses minimal. What really set the 860 apart was Massey Ferguson's attention to operator comfort and control. The cab was spacious, well insulated against noise and dust, and positioned to give excellent visibility. The control layout was logical, with key adjustments easily accessible. Instrumentation provided real-time feedback on engine performance, grain loss, and system status. For 1974, this was sophisticated monitoring. The 860 found particular success in diversified farming operations. It handled small grains excellently, but also performed well in soybeans and other crops. Massey Ferguson's global presence meant the 860 sold well, not just in North America, but in Europe and other markets. Production continued through the late 1970s, and many 860s remained in service well into the 1990s. Today, well-maintained examples are prized by collectors who appreciate Massey Ferguson's combination of power and refinement. The 860 proved that British engineering could compete with American manufacturers in the demanding harvest equipment market. Number 8. International Harvester 141. Moving up to number 8, we're looking at the International Harvester 141. Introduced in 1946 as one of IH's first self-propelled combines. While it might not have the raw power of later machines on this list, the 141's significance in harvesting history cannot be overstated. The 141 featured a 4-cylinder gasoline engine producing approximately 60 horsepower, driving both the ground wheels and the internal threshing mechanism. The cutting platform was typically 10 to 12 feet wide, and the machine incorporated IH's proven cylinder and concave threshing system that dated back to their pull-type combine experience. What the 141 lacked in sophistication, it made up for in rugged dependability. International Harvester built the 141 tough. The frame was heavy steel construction designed to handle rough field conditions. The drive system used robust chains and sprockets rather than complex transmissions. This meant more weight and some inefficiency, but it also meant reliability. Farmers could fix most problems with basic tools and common sense. The simplicity was intentional. IH knew their customers valued machines they could maintain themselves. The 141 became particularly popular in the Midwest corn and soybean belt. Its capacity suited medium-sized farms perfectly. You didn't need hundreds of acres to justify a 141. A 100-acre grain operation could keep one busy and pay for itself within a few seasons. IH's extensive dealer network meant parts and service were readily available, crucial for machines that needed to work through short harvest windows. Production of the 141 and its close variants continued into the early 1950s, with thousands built. Many farmers operated their 141s for decades, only retiring them when parts became scarce or when farm size expanded beyond the machine's capacity. The 141 wasn't flashy, wasn't revolutionary in individual features, but it was exactly what thousands of farmers needed: an honest, reliable workhorse that harvested grain without drama. Today, surviving 141s are beloved by collectors for their historical significance and straightforward mechanical design. They represent an era when combines were tools, not complex computer-controlled systems. And sometimes simple tools are exactly what gets the job done. Number 7, Gleaner N6. At number 7 is the Gleaner N6, introduced in 1972 by Ellis Chalmers and representing a fundamentally different approach to combine design. While most manufacturers used conventional cylinder and straw walker systems, Gleaner pioneered rotary separation, and the N6 was their breakthrough machine. The N6 featured a 6-cylinder diesel engine producing approximately 180 horsepower, substantial power for 1972. But the real innovation was the rotary separator system. Instead of using straw walkers to shake grain from straw, the N6 used a large rotating cage where crop material tumbled and separated through centrifugal force. This design offered significant advantages: gentler handling of grain, better separation in tough conditions, and simpler mechanical design with fewer moving parts. The rotary system meant the N6 could handle difficult crops that challenged conventional combines. Tough-to-thresh varieties, high moisture grain, tangled or down crops. Situations that would plug or overload straw walker machines were handled smoothly by the N6's rotating cage. Farmers in areas with variable harvest conditions appreciated this versatility. You could run the same machine effectively through wheat, soybeans, corn, and specialty crops without constant reconfiguration. Gleaner designed the N6 with excellent capacity. The grain tank held 60 bushels, among the largest available in the early 1970s. The cutting platform could extend to 24 feet with optional headers, serious width that allowed covering ground quickly. The cab provided good visibility and comfort, important for operators spending 12-hour days harvesting. The N6 developed a loyal following, particularly in the Central Plains and among farmers who valued innovation. Gleaner's smaller market share compared to John Deere or Case IH actually worked in their favor. N6 owners felt like they were part of a knowledgeable club, people who understood that rotary separation was superior. Many farmers who bought N6s never went back to conventional combines. Production continued through the 1970s, and the N6 evolved into later Gleaner models that refined the rotary concept. Today, virtually all combines use some form of rotary separation, a direct legacy of Gleaner's pioneering work. The N6 proved that thinking differently could produce better results. It wasn't just powerful, it was smart. Number 6. Case IH 1680 Axial Flow. Number 6 brings us to the Case IH 1680 Axial Flow, introduced in 1907 and representing Case's answer to rotary combine technology. If the Gleaner N6 proved rotary separation worked, the 1680 proved it could dominate the market. The 1680 featured a turbocharged diesel engine producing approximately 190 horsepower, channeled through Case's sophisticated axial flow rotary system. Instead of Gleaner's transverse rotor, Case used a longitudinal design where crop material entered at the front and moved axially through a rotating cage. This design provided even more aggressive separation and could handle higher throughput volumes. What made the 1680 truly revolutionary was its combination of capacity and simplicity. The axial flow system had fewer components than conventional combines. No straw walkers, no complex shaker mechanisms, just a rotating cage doing all the separation work. This meant less to adjust, less to maintain, and less to break. Farmers appreciated the simplicity, especially during harvest when downtime meant lost income. The 1680's capacity was impressive. It could process grain at rates that would overload conventional combines of similar engine power. The grain tank held 180 bushels, and the unloading auger could empty it in under 2 minutes, crucial for keeping the machine moving. Cutting platforms up to 30 feet wide were available, allowing serious ground coverage. Case marketed the 1680 aggressively, and it quickly gained market share. Farmers who switched from conventional combines reported significant productivity improvements. The axial flow handled tough conditions better, operated more consistently, and required less constant adjustment. Word spread, and soon the 1680 was challenging John Deere's dominance in many markets. The 1680 remained in production with updates and improvements well into the 1990s, eventually evolving into later axial flow models. Its success transformed Case IH into a major player in the combine market. Today, the 1680 is recognized as one of the most significant combines ever built. The machine that proved rotary technology could be both powerful and practical at commercial scale. Number 5. New Holland TR70. Coming in at number 5 is the New Holland TR70, introduced in 1975 and representing New Holland's entry into rotary combine technology. After years of building conventional combines, New Holland made a bold bet on rotary separation, and the TR70 delivered. The TR70 featured a 6-cylinder diesel engine producing approximately 165 horsepower, driving New Holland's twin rotor system. This was unique. Instead of one large rotor like Gleaner or Case, New Holland used 2 smaller counter-rotating rotors positioned side by side. Crop material was split between them, with each rotor handling half the volume. This design provided exceptionally gentle grain handling and thorough separation. The twin rotor concept offered several advantages. The smaller rotor diameter meant lower rotational speed for equivalent peripheral speed, resulting in less grain damage. The counter-rotation created unique flow patterns that improved separation efficiency, and having two independent rotors provided redundancy. If one side had issues, the machine could still operate, though at reduced capacity. New Holland engineered the TR70 for versatility. It excelled in small grains, but also handled corn, soybeans, and specialty crops effectively. The machine was popular in diversified farming regions where flexibility mattered more than specialization in a single crop. The grain tank held 140 bushels, reasonable capacity for the era. The cab design was advanced with excellent visibility and surprisingly good climate control. The TR70 found particular success in the eastern United States and parts of Europe, where farms tended to be smaller and more diversified than Great Plains operations. The machine's size and capacity suited these operations perfectly. New Holland's dealer network provided solid support, crucial for a new technology that farmers were initially skeptical about. Production continued into the 1980s as New Holland refined the twin-rotor concept. Later models increased capacity and power, but the TR70 established the fundamental design. Today, New Holland continues using twin-rotor technology in their combines, a direct lineage from the TR70. The machine proved that there wasn't just one way to do rotary separation. Innovation could take multiple paths to the same goal. Number 4. John Deere 7720 Titan. At number 4, we're looking at the John Deere 7720 Titan, introduced in 1972 and representing Deere's response to increasing demands for harvesting capacity. This wasn't just an incremental update. The 7720 was a completely redesigned machine built for serious production. The 7720 featured a turbocharged 6-cylinder diesel engine producing approximately 215 horsepower, massive power for the early 1970s. John Deere channeled that power through an advanced variable speed drive system and sophisticated hydrostatic transmission that gave operators unprecedented control. You could adjust ground speed on the fly without touching engine RPM, crucial for matching varying crop conditions. The 7720 used conventional cylinder and straw walker separation, but Deere engineered every component for maximum capacity. The cylinder was larger diameter with aggressive rasp bars. The concave area was extended for longer threshing time. The straw walkers were longer and more aggressive than previous models. The cleaning shoe was wider with more air volume. Everything was sized to handle high throughput without compromising grain quality or excessive loss. The grain tank held an impressive 180 bushels, among the largest available when introduced. The unloading auger was positioned high and could swing wide, allowing emptying into trucks while still moving through the field. This on-the-go unloading capability saved enormous time during harvest. Optional cutting platforms stretched to 30 feet wide, serious ground coverage that let the 7720's power shine. Deere paid particular attention to operator experience. The cab was spacious, quiet, and comfortable. The control layout was logical, with critical adjustments easily accessible from the operator's seat. Instrumentation provided detailed information on machine performance, grain loss, and system status. For the early 1970s, this was sophisticated monitoring. The 7720 became legendary in wheat country. Custom harvesters loved them for reliability and capacity. Large-scale grain farmers who needed to cover over hundreds of acres quickly adopted them enthusiastically. Production continued until 1983, with thousands built. Many 7720s remained in service for decades, testament to Deere's build quality. Today, well-maintained examples command premium prices. The 7720 Titan earned its name. It was truly titanic in capability and influence. Number 3. International Harvester 915. Breaking into our top 3 at number 3 is the International Harvester 915, introduced in 1975 and representing IH's most powerful conventional combine. The 915 was International's statement that they could match anyone in the industry for sheer harvesting capability. The 915 featured a turbocharged V8 diesel engine producing approximately 230 horsepower, massive power that gave the machine incredible capacity. International channeled that power through their hydrostatic drive system, providing infinitely variable speed control that let operators match exactly to crop conditions. The hydrostatic transmission was smooth, responsive, and allowed precise control impossible with traditional gear drives. International engineered the 915 with their axial flow separation system, not to be confused with Case's later use of the name. IH system used conventional cylinder and straw walkers, but arranged them in an optimized configuration that maximized separation efficiency. The cylinder was extra large diameter with aggressive threshing action. The straw walkers were long with sophisticated shake patterns. The cleaning shoe featured powerful air blast and large sieve area. The result was a machine that could process grain at rates exceeding most competitors. The grain tank held 200 bushels, enormous capacity that reduced time wasted on unloading trips. The unloading auger could empty in under 2 minutes, crucial for maintaining productivity. Cutting platforms up to 30 feet wide allowed the 915 to show its power, covering ground at speeds that challenged operators' ability to keep up. IH designed the 915 specifically for large-scale operations. This wasn't a machine for small farms. It was built for wheat country, custom harvest operations, and farmers working thousands of acres. The cab was spacious and comfortable because IH knew operators would spend 12 to 14-hour days harvesting. Visibility was excellent, and the control layout reflected input from experienced operators. The 915 developed a devoted following among farmers who valued power above all else. In wheat harvest races, informal competitions to see who could cut the most acres in a season, the 915 consistently topped leaderboards. But International's financial troubles in the early 1980s meant production was relatively short. Many farmers who wanted 915s couldn't get them, as IH struggled with broader corporate issues. Today, surviving 915s are rare and highly valued, representing International Harvester at the peak of their capabilities before circumstances beyond the engineering department's control changed the company's trajectory. Number 2, Claas Dominator 108. Taking the number 2 spot is a machine that might be unfamiliar to American farmers, but was revolutionary in Europe. The Claas Dominator 108, introduced in 1976 by German manufacturer Claas. This machine represented European engineering excellence applied to harvesting. The Dominator 108 featured a 6-cylinder Mercedes-Benz diesel engine, producing approximately 200 horsepower, channeled through Claas's sophisticated drive system. What made the 108 special was Claas's obsessive engineering refinement. Every component was optimized for efficiency and reliability. The threshing cylinder used a unique tooth design that Claas developed through extensive testing. The straw walkers incorporated innovative shake patterns. The cleaning shoe used airflow management techniques ahead of competitors. The result was a machine that achieved exceptional grain quality with minimal losses. European grain markets often paid premiums for properly threshed, undamaged grain. The Dominator 108 delivered that quality while maintaining high capacity. The grain tank held 150 bushels, smaller than American machines but appropriate for European farm sizes and road transport regulations. Claas engineered the Dominator 108 for versatility across diverse European conditions. It handled wheat, barley, and other small grains excellently. It performed well in corn and soybeans. It could even handle specialty crops like rapeseed that challenged other combines. This versatility was crucial for European farmers who typically grew multiple crops on relatively small fields. The cab design was sophisticated, with excellent visibility, low noise levels, and intuitive controls. Claas paid particular attention to serviceability. Panels opened easily, key components were readily accessible, and maintenance routines were straightforward. European farmers, like their American counterparts, valued machines they could maintain themselves. The Dominator 108 achieved strong sales in Europe and other international markets where Claas had distribution. It competed successfully against American brands, proving that combine technology wasn't exclusively American. Some units made it to North America, where farmers appreciated the engineering quality. Today, Claas remains a major combine manufacturer, still building machines that embody the engineering philosophy pioneered in models like the Dominator 108. Number 1, John Deere 8820, and taking the number 1 spot on our list is a John Deere 8820, introduced in 1970 and representing the ultimate evolution of conventional combine technology before electronics took over. When farmers talk about legendary combines, the 8820 is always in the conversation. The 8820 featured a turbocharged and intercooled six-cylinder diesel engine producing approximately 260 horsepower, the most powerful production combine available when introduced. John Deere engineered every aspect of this machine for maximum capability. The variable speed hydrostatic drive provided infinite control. The conventional threshing system used an oversized cylinder, extended concave, longer straw walkers, and massive cleaning shoe, all optimized to handle the power. But the 8820's greatness came from more than just specifications. John Deere built it to be an operator's machine. The cab was the best in the industry, spacious, quiet, comfortable, with visibility that let you see exactly what was happening. The control layout reflected decades of user feedback, with every adjustment positioned logically and responding precisely. The instrumentation provided real-time data on performance, allowing operators to optimize constantly. The grain tank held a massive 220 bushels. You could harvest for extended periods before needing to unload. The unloading auger could empty while moving, crucial for maintaining productivity. Cutting platforms up to 30 feet wide let the 8820 demonstrate its capability, and Deere's dealer network ensured support anywhere in North America. The 8820 became the machine of choice for serious farmers and custom harvesters. It could harvest wheat at over 100 acres per day in good conditions. It handled corn, soybeans, and other crops with equal competence. Reliability was legendary. Many 8820s logged thousands of hours with only routine maintenance. Some remain in service today, over 40 years after manufacture, still harvesting grain competitively. Production continued until 1989, when electronic controls and further refinements created new model lines. But the 8820 remains the standard against which vintage combines are measured. It represented the pinnacle of mechanical combine engineering. After the 8820, computers and electronics began taking over. The 8820 was the last great purely mechanical combine, and it was glorious. Today, well-maintained examples command premium prices at auctions. Collectors recognize what farmers always knew. The 8820 was the ultimate vintage combine harvester. And there you have it, the top 10 most powerful vintage combine harvesters ever built. From the pioneering John Deere 55 to the legendary 8820, these machines represent the evolution of harvesting technology during the golden age of mechanical engineering. Each one pushed boundaries, solved problems, and helped farmers feed the world during a crucial period when agriculture was modernizing rapidly. They're reminders that before GPS and yield monitors, engineers created incredible machines through pure mechanical excellence and deep understanding of what farmers needed. Which one impressed you most? Do you have memories of operating any of these legendary combines? Maybe your family farm still has one working? Drop your thoughts in the comments below. We love hearing from people who actually ran these machines. And if you enjoyed this journey through harvest history, don't forget to hit that like button, share this video with fellow farming enthusiasts, and subscribe for more deep dives into the machines that built modern agriculture. Thanks for watching, and we'll see you in the next one.